Okay, so I'm going to give you 12.7 to look at today. Um, it's all about whether functions are increasing or decreasing. So remember that dy by dx works out the gradient at a point. And so if the value of the gradient, dy by dx, is positive, the curve must be going up. And if dy by dx is negative, the curve is basically going down. So if you look at this first example here, which I'll go over in red, this curve is always going up. It slows down and it might just flatten out to a gradient of 0. But essentially, the gradient is increasing. So we call it an increasing function. So if you look at what's written in this box here, that curve, so if you imagine that that point there, dy by dx, was still greater than 0. So it's not quite flat yet. M is still greater than 0. Then that's an increasing function. Now, sometimes there's a bit of a confusion between whether it's strictly increasing or increasing. So we're going to say that increasing means that you can include the possibility at some point it's perfectly horizontal and flat. So that's an increasing function. So for example, y equals x cubed would be an increasing function. But functions obviously can be increasing, decreasing over different domains. So for example, if everything to the left of this coordinate here, which is an x coordinate of 2, is increasing, because at any point, if you drew a tangent, it'd have a positive gradient. Whereas between x equals 2 and x equals 4, if you drew a tangent at any point, it'd be negative. The gradient would be negative. So it's decreasing for x between 2 and 4, increasing x is less than or equal to 2, and you can see it's definitely increasing after that, after x is greater than 4. And so that's what we're going to look at, is ideas of increasing, decreasing functions. And as I said, for simplicity, we're going to say that increasing up is more than or equal to 0 and decreasing down is less than or equal to 0. So if you look at this first example, let's find the interval for which the function is decreasing. And we're just going to use the graph and estimate. Decreasing means a negative gradient. Yeah? A negative gradient. Or you could say dy by dx is negative. Now hopefully you can see that at the turning point, that's where, let's estimate the turning point there, right? That point there. And I make that a half if it's a good estimate, yeah? If 1 would be there, that's a half. Let's say the turning point's at a half. Everything to the left of a half, well, if you do the tangent, again, clearly positive gradient. But everything to the right of a half, see the gradient's negative. So what we can say is f of x is decreasing in the interval x is more than or equal to a half. For any value more than a half, that gradient will always be negative. So this time they gave us a gradient function. We're going to find out when it's increasing. So remember, increasing means that. So we want that to be increasing. Now, you can solve that on your calculator. You can simply use the quadratic solver. They may make it hard in the exam. So what I'm going to do is I'm going to solve that I'm going to solve it by hand. So I'm going to factorize out an x. Well, I'm going to factorize out a minus x. 12x squared minus 13x. So that would become a plus 13 if we took a negative out. And then we're looking for solutions to that quadratic. Well, one solution is definitely 0. All right. So I'm just going to put that there. Which makes sense because if you look at that point 0 there, it's flat. And there's a point that's flat there, there's a point that's flat there. Now I haven't got my calculator to hand. Let's say, for argument's sake, the roots of this quadratic are x equals a, x equals b. Okay? Then, and let's say a is here, and let's say b is there. Now I'm just going to interpret the answer in terms of a, b, and obviously the point 0 here. Well, the gradient in this region is positive, so that's increasing. Between a and 0, you're going down. So in this region, it's decreasing. And then in the next region, between 0 and b, it's increasing again. The gradient's up. And then you can see the graph suggests that anything after b is constantly going down. We want to know when it's increasing. So increasing was anything to the left of a, or you could be between 0 and b. Now, if you use your quadratic solver, that should have come out straight away. Now you can test it yourself because you're going to be doing this key skill a few times today. Okay, so in this one, all we're given is the original curve. So in the last one, we were given the differential. So obviously, the only thing we're going to do this time is to do the differentiating ourselves first. Okay, so I've differentiated this. We want to know when it's increasing, so therefore we want to know when that's greater than 0. So that's 9x squared plus 24x minus 9 greater than or equal to 0. And we simply solve that. Now that's presumably got some roots, and then we work out there. So I haven't got my calculator with me. In fact, yeah, I'll just do it by hand. So 9 times minus 9 is minus 81. I want two things at times to make minus 81. Add to make 24. In fact, this might be decimal. Let me think. 9. Oh, it's 3 and 27, isn't it? So, would 3 and 27 work? 27 take away 3, yeah. 27 take away 3. And so it's 9. Just quickly showing you how to do it without a calculator. So I'm looking for the roots by doing this. Okay, so the factorized form of that is 9x minus 3, x plus 3. And we want that greater or equal to 0. Well, that makes the roots a third and minus 3. It's a positive quadratic, so it goes positive, negative, positive. I want to be positive, so I'm to the left of that and to the right of that. So the answers are x is less than or equal to minus 3, x is greater than or equal to a third. But remember, your calculator would have gone from there to there if you use the quadratic solver. It says exact in this one. So first thing, let's turn that term into minus 32x to the minus 1. Now, because they use f of x notation, I have to use f dash notation, not dy by dx. So that would be minus 3. Minus 1 times minus 32 is plus 32, x to the minus 2, and the minus 20 is a constant, it disappears. We want it to be decreasing, so we want f dash x to be less than or equal to 0. Right, so we've got minus 3. I'm going to write that as plus 32 over x squared. So now what I'm going to do is take the 3 to the other side. Now, x squared is always positive, which means I know the sign won't flip if I do this, if I times by it. So x squared is greater than that. Right. Find the exact interval for which it's decreasing. Well, that's going to be true if x is bigger than the positive square root or if x is less than the negative square root. Now, root 32 is 16 root 2, so you could also, I mean, your calculator will do this for you. 32 is 16 times 2, so that would be the same as 4 root 2, I believe. So that's an alternative way of writing it. Now, I'm going to pause there so you can have got the key skills and also these questions before I make the next video.